Hello. Yesterday I explained a topic in physics called angular momentum. Today I'll try to explain a topic in quantum physics which is called superposition. Now, a superposition is a pretty complex topic, but I'll try to break it down as simple as possible. So if you have any questions, just please let me know. So, a superposition states that a system can be in multiple states at once, like at the same time, before it's measured. I'll give an example. So there was a theoretical experiment brought up by a scientist named Schrödinger, and the experiment is like this. Let's say we have a box, and in a box we have a cat, a radioactive atom, a Geiger counter, a hammer, and a vial with poison. Now, once the radioactive atom decays, the Geiger counter picks up radiation. As it picks up radiation, it triggers the hammer into breaking the vial. Now, once the vial is broken and releases poison, the cat is either dead or alive. Now, the cat is in a superposition, because we won't know unless it's dead or alive unless we open the box. Now, before we open it, the cat is in a superposition. Now I'll go a little more detailedly, but now I'll use a whiteboard for that. Now I'll talk more about superposition with you a little bit of math. Don't get too worried about this, I'll break everything down. So the important thing you're supposed to know about quantum mechanics is that you're not using any particles nor waves. Everything is described in a complex wave function. So now let's take a look at the Schrödinger's equation. Don't get too worried about how complex it might seem. The most important part is that the solutions to the equations are the possible things the system can do. And for example, if you have two solutions, their sum is also a solution, which is also a superposition. Now you can measure a probability of an outcome with an absolute square of psi. Psi is just the symbol of a wave function. Okay, so this might seem a little bit scary, but it's not, like I said. So now we can use our initial solutions to find their superposition, which is going to be their sum and their difference. Now when we found their sum and difference, we got another superposition, like we got another solution. Now we can just simply say that psi1 is equal to psi3 plus psi4. The same way how we can say psi3, the difference of psi3 and psi4 is equal to psi2. Now, with all of these solutions, which one is actual superposition? Well, there is no answer. Why? Because a superposition is not an absolute term. It depends on your choice of a specific set of solutions. Like Schrödinger's cat is not in a superposition of dead and alive. Instead, it's in a non-superposed state of dead and alive. Now, I can go further with this, but that's a bit more complex and involves entanglement, which is for another time. So for now, goodbye.